A current carrying conductor is associated with magnetic field around it. This is called the magnetic effect of current and was discovered by H.C. Oersted in 1820. This magnetic field is in the form of concentric circular lines around the conductor, and the direction of the field is determined either by the right-hand thumb rule or by the Maxwell's corkscrew rule. Now what happens if the current carrying conductor is placed in a magnetic field? Its own magnetic field interacts with this magnetic field and experiences a force which is equal to BIL sin theta, where B is the strength of the magnetic field, I is the current passing through the conductor, L is the length of the conductor, and theta is the angle between the current carrying conductor and the magnetic field. Now it is obvious that the force is maximum when sin theta equal to 1 or theta equal to 90 degrees. Or in other words, the direction of current and magnetic field are perpendicular to each other. The direction of force is given by Fleming's left-hand rule. Stretch the forefinger, central finger and the thumb of your left hand mutually perpendicular to each other like this. If the forefinger points in the direction of the magnetic field and the central finger in the direction of the current, then the thumb points in the direction of the force experienced by the conductor. This is the principle of electric motor. It contains a horseshoe type field magnet with concave poles, an armature coil which is rectangular in shape. Notice that the axis of rotation of the coil is perpendicular to the direction of the magnetic field. A split ring commutator made of metal, its function is to reverse the current direction after every half rotation. Graphite rods called brushes, which is in contact with the split rings, a battery, and connecting wires connected to the brushes. What happens in this position? The direction of current is like this over here. The direction of field is here. Applying Fleming's left-hand rule, the direction of force is here. These two forces make the coil rotate anti-clockwise. After half rotation, the direction of current reverses. That is, this part of the commutator is now connected to the positive terminal. Applying Fleming's left-hand rule again, we get the direction of force. Now this part of the coil goes down and this part moves up, which is just the reverse of what was happening on the previous half cycle.